All right. So problem number 1 says we have this 3x5 index card, and we're going to cut the corners out, same size corner, and that's going to create a shape. Now, being I'm cutting a square out, all these dimensions as you go around are x, 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 x. And so they want, in this case, x to be 0.5. Okay? So that means that this distance here and this distance here will be 5 minus 0.5 minus 0.5. So this little distance here is 4 and 4. This little distance here is 3 and 3. 3 minus 0.5 minus 0.5, so that's a 2 and a 2. And then I have a 0.5. So that means the volume of this particular box is going to be 4 by 2 by 0.5. So that's 8, half of that. So I get 4 cubic inches. Okay, so that's one way of dealing. We didn't have to go into it. And then it says, hey, what if, so that goes along, calculate the volume, so we have the volume. So that's number 2. So number 3 says, what if we did 1-inch cutouts? What if we did 1-inch cutouts of our 3x5 card, which kind of looks like this? So the things I know is that's 1 and 1 and 1 and 1. 1 and 1. And then this distance here was 5, so it's going to be 3. This distance here was 3, so now it's 1. So the volume of this is going to be 1 times 1 times 3. So I get 3 cubic inches. Okay? Let's see. Okay? And then write an equation that will give you the volume of the box if you cut out just a size x. So you're going to have a volume of 5 minus 2x and 3 minus 2x by x. This is your volume equation if you had just size x. And then if you wanted to figure out what's going to create, what little squares can you cut off on each side that are going to create you the most ideal or largest volume box. So we can do that. All right. So I'm going to get to our Desmos friends. And graph it. So y equals 5 minus 2x. 3 minus 2x and x. So all you're looking for is that one max right there. So if you made a 0.607 by 0.607 cut in each of the corners and fold up the sides, your maximum volume of your box would be 4.104 cubic inches. Okay? Things that you ignore on this, you ignore the minimum, because you can't make a 2-inch cut because your side that's 3 inches, you overlapped it, so that's not going to exist. So underneath the x-axis doesn't exist. All of the values here, like if you were just come up, if you made a 0.1 inch, so notice how as I'm going up this, the volume's changing, and the volume is the y component as I come up, until I get all the way up to that 4.104, and that's the max. And then as it's coming back down, the x value is our inch cuts in the side to go with that. Okay? So, my friends.
Oh, we have that quiz there.
Small one, SML. All right. So I have a question for you. How would I, if I had this, how would I find the derivative of this? And the answer would be, well, you could multiply it together, absolutely. So you're going to get 5 minus 2x times 3x minus 2x squared. And then just FOIL this. So that's going to give me 15x. That's that. Minus 10x squared. Minus 6x squared. Plus 4x to the third. Clean it up. So your volume equation is 4x to the third minus 6x squared minus 10x plus 15. And if I wanted to find the derivative of that, it's just going to be this. Minus 12x minus 20. Oh, there should have been x with that. 20x plus 15. Okay, and so this gives us a parabola, so you just have to find the local max or min, and that would be your turning point. So what I will mark off tomorrow during our whopping long 20-minute period, if you're not here, then I'll mark it off on Thursday, is make sure the index card back and front is done. And I'll mark it off on Wednesday if you're here. If you're not here, then I'll show me on Thursday. Oh my gosh. So there are some things that old people shouldn't have. You know what Dad just discovered on his phone? That he can go into the message thing and take a picture and send it. I've gotten about 120 photos that my father has taken over the past 5 or 6 days. Hey, look at this. It's like he's taking pictures of gravestones. Hey, this is your cousin Gracie. I don't know who cousin Gracie is. I've never known who cousin Gracie is. Okay,